Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. Today I would like to present report progress for this semester. My research title is Modeling of Aqualaria melicensis oil into 6 grades using K-nearest neighbor model. So my name is Mohammad Arif Fahmi binti Hassan, student ID 202228938 for semester 3. My program is CEE 750, Master of Science in Electrical Engineering. My supervisor is Professor Madya IRTS Dr. Nurlaila binti Ismail, and my co-supervisor 1 is Prof. IRTS Dr. Haji Muhammad Nasir bin Taib, and co-supervisor 2 is TS Dr. Zakiyah binti Muhammad Yusuf. And for date of registration is 1st October 2022. And right now I'm in the duration of in the program is 16 out of 24 months. So the slides consist of first review papers, current progress, future works, Gantt chart, and achievements. So this is the list of review papers that I have used in this research slides making. So for review papers, I would like to introduce about the Aqualaria melicensis. So in Malaysia, agarwood is a dark resinous hardwood which comes from the main genus Aqualaria melicensis. In order to produce resin content from agarwood, it is undergoing the process of inducement either by injury, disturbance from insects, and microbial invasions. Agarwood is demanding due to its special applications, so the agarwood is widely used as a perfume, fragrance, and in soap manufactures due to its unique scent. In Middle East, the agarwood is used in a wedding ceremony, while in India produce an oil known as minyak attar for Muslim purpose. Furthermore, in Malaysia, some ethnic use agarwood oil as an insect repellent, treat liniments or other body pain. The agarwood oil is graded according to its grading classifications, either high quality or low quality. High quality agarwood oil has a dark color and long lasting aroma, as well as the price compared to the low quality. Okay, next I will explain about the review papers of Pearson's correlation coefficient. So the Pearson's correlation coefficient is denoted by the rho of R is a measure of the linear between variables x1 and x2. It ranges from -1 to +1, while with 0 indicating no correlation, +1 indicating the perfect positive correlations, and -1 indicating a perfect negative correlations. The absolute value of R indicates the strength of the correlation, with the values closer to +1 or -1. The strength of the correlations becomes greater from 0 to +1 and from 0 to -1. The correlation coefficient of 0.6 has been used frequently in research as the minimum limit in accepting the relationship between two variables. So for the current progress is for the model development. There are 11 chemical compounds for correlation coefficient of PC1 and PC2 after Verimax rotation. The correlation coefficient ranged from 0.6 to 0.1. So as we can see that these 11 chemical compound, the highlight yellow one is the chemical compounds, the R values that shows the high correlation coefficients. As we can see from this table 2 correlation coefficient of agarwood oil chemical compounds, we can see that the pink color is negative 0.3, which is the low correlation coefficient, and the red color is the correlation coefficient, which is above 0.6. So as we can see from this table, the variable between alpha agafurans and beta agafurans is 0.677, while 10 epi gamma udesmol with beta agafurans give the correlation coefficient 0.626, and the 10 epi gamma udesmols and alpha agafurans give the values of 0.741. So for the current progress, there are three compound pairs that have correlation coefficient larger than or equal to 0.6, which is beta agafuron and alpha agafuron, beta agafuron and 10 epi udesmol, and alpha agafuron and 10 epi udesmol. Their correlation coefficient is ranging from 0.6 to 6 to 0.741. So the direction of correlation coefficients for these pairs are all positive, and therefore they are proportional to each other. So this is the tables of correlation coefficient pairs, which is R less than 0.1, which is the less significant values of correlation coefficients. So we can conclude that these variables are non-significant since they give the R value is less 0.1. So table 3 shows the compounds that have correlation coefficient less than 0.1. Their correlation coefficient ranging from negative 0.062 to 0.074. The compound pairs for aluminium epoxide and alpha agafuron, dihydrocolumularin and varelenol shows the negative correlation coefficients, which are negative 0.062 and negative 0.021 respectively. These negative R indicates that the attributes are inversely related. So from this table, it's found that there are 14 chemical compounds pairs that have correlation coefficient less than 0.1. So using percent correlation, the non-significant chemical compounds from PCA were filtered. Only compounds with correlation coefficient less than 0.1 is selected. The compounds of aluminum epoxide, dihydrocolumularin, valerenol, alpha-guanine, gamma-udesmol, gamma-cadhenin, and beta-dihydroagafuron. So for future work is running the non-significant compounds as input for SOM. Second is running the most significant compound as input for self-organizing math, and then both result compare. And third is validations of result, which is run the KNN and check the accuracy. So for the list of contributions, I have submitted a paper of review papers titled Self-Organizing Map Application for Modeling Accelera Malacensis Oil Quality for BEE papers. So this is the Gantt charts for this semester. And then that's all from the slides presentation. Thank you.